of this video is to define a fine soil under the Unified Soil Classification System, and we're going to be looking at these things called the Atterberg Limits. So the first thing is this Unified Soil Classification System. So this is a system for defining a soil type, and I've summarized this in this flowchart, which is going to be seen in the next couple of videos. So the first branch in our flowchart is the amount passing through 0.075 millimeters. And we saw in the previous video that was the critical value for a fine or a coarse soil. So we first need to work out how much of our soil sample can pass through 0.075 millimeters, and for a fine soil, more than 50% passes through, which is going to take us to this thing called the Plasticity Chart. Okay, it's very simple for a fine soil, but for a coarse soil, you can see that it's quite a long process. It looks very confusing, but when we do a couple of examples, you'll see it's not that hard at all. And the reason I'm doing the fine soil first is because we come to this thing called the Plasticity Chart, which could come up later for a coarse soil, depending on which branch you go down. So you can see it's down here as well. So this is the Unified Soil Classification System, and we're going to be defining what a fine soil is. So a fine soil is simply when the majority of our soil sample, so say this was our sample, when the majority of it, so more than 50% being the majority, has particle sizes less than 0.075 millimeters in diameter. So we can see that we would have a sample where the majority is these small particles. We could have a couple big ones, but the majority, i.e. more than 50%, has particle sizes less than 0.075 millimeters. The next thing we need to look at for a fine soil are these parameters called the Atterberg Limits, and these only exist for a fine soil, and you're going to see in a second why. The first thing we have is the plastic limit, which we can abbreviate to PL. The second thing we have is the liquid limit, which we can abbreviate to LL, and the third thing we have is the Plasticity Index, which we can abbreviate to I subscript P. So what are these things? These things are defined because a fine soil isn't like the soil you see in your garden. A fine soil has very, very small particle sizes, and it doesn't behave like the soil you get in your garden. When you go to your garden and you pick up a sample soil in your hand, you'll see that the soil is quite grainy and it's quite large, the particle sizes, when they come together. However, a fine soil has very, very small particle sizes, and when you mix a bit of water in, it behaves more like a foam. Okay, it doesn't behave like the soil you see in your garden. It's a bit weird to see. So we have these two limits for such a soil. So let's just say we've got our normal fine soil here. So we have very, very small particle sizes, and what happens is because it behaves like a foam, it exhibits properties of cohesiveness and plasticity. So it can hold itself together, and it can also take the form of the container you put it in. So it's sort of taking the form of the beaker here. Now there's two limits to this. We can increase the moisture content, so we're just adding water, to such an extent that the fine particles now become suspended in the water. So this is called the liquid limit, and it's the point at which particles, the solid soil particles, become suspended in a liquid, so in the water. And the other spectrum is when we decrease the moisture content, so we decrease the amount of water to such an extent that the sample dries out. So we start getting these cracks in the beaker, in the sample of soil, so that the sample no longer behaves like a plastic material. It no longer really takes the form of the container. It no longer behaves like a plastic material, and we call this the plastic limit. So we have these two limits to a fine soil. We can increase the moisture content such that the solid particles become suspended, and we can decrease the moisture content such that the soil no longer behaves like a plastic material. And these are the limits. Obviously you can go far beyond this, but this is the point at which it becomes suspended and the point at which it becomes no longer behaving like a plastic material. The third thing we need to define is this Plasticity Index, I subscript P, which is equal to the liquid limit minus the plastic limit. We're going to be using these definitions in the next video to actually define a soil, but just quickly to summarize, we're just looking on the flowchart for a unit. So this is under the Unified Soil Classification System, which is used very broadly. The first thing on the flowchart is the amount passing through 0.075, and for a fine soil, when the majority of that is less than 0.075, we're going to come to something called a plasticity chart, which we'll see in the next video. Hope that helps, guys.